Hello everyone, welcome back. Okay, so now we're going to start working with those stress elements, working with those strain elements, and seeing if we can actually solve some problems. So what we have right here is a stress element, and it tells us these stresses. We have normal stress in one direction and the other, and also our shear stresses. Remember, all those shear stresses are equal. And so what do we want to find? Well, we want to determine the principal stresses, as well as the maximum in-plane shear stress acting at a particular point. And we're going to show this on an appropriate sketch, and then finally find the absolute maximum shear stress at the point. In plane versus absolute maximum is just saying that, honestly, there are going to be shear stresses caused by the z direction sometimes. Maybe not in this particular example, but in some. And so we have to figure out if that's going to be an issue. Okay, so for our given stress values, they are the stress in the x direction, the stress in the y direction, and the shear stress that was given to us. Why is it negative? Well, let's look back at the picture. And what we see here is that it's pointing in the negative y direction on the positive x side. It should be pointing in the positive y direction if it's positive. So don't forget that. Okay. So the principal stress magnitudes can be computed from our equations. We don't actually have to do anything. You just plug it into our equations. Now remember, I wrote these a little bit differently when I was going through the PowerPoint, but this is what you have in your textbook. So if we do that, we plug it in, remembering that this is your average stress. If you want to just take a little shortcut right there, we can see the difference. Also, this kind of points at Moore's circle. So if you really like Moore's circle, you could do this. This right here would be the radius of the circle. This would be the center of the circle. And then from that, you can get all the stress states. So if you drew that, you'd find some point like this. That's the average. And then from that, you could say, okay, well, here's principal 1, here is principal 2. And so we get is it's going to be 38 plus or minus 21.9317 KSI. So principal stress 1 is the bigger of the two, 59.9 KSI. Principal stress 2 is 16.07 KSI. And then our shear stress max is going to be 21.9 KSI. That's the maximum in-plane shear stress. So that is the radius. So if you look at this one right here, that was the max shear stress right there. Then finally, our average shear stress is going to be 38 KSI, which is taken from right here. So we get a whole lot of information just from one equation. Okay, but what about the absolute maximum shear stress? Well, we got some more work to do before we can get there. Another thing to think about is what angle do we have to rotate our stress element to get to these principal axes? Once again, it's just plug and chug. You have this equation. It's already in your textbook. It's in the PowerPoint. You plug in all of your stresses, being very, very careful about the direction. And what you get then is that you have to turn 21.6 degrees clockwise from the x-axis to get to the direction of their principal 1. And so it would look something like this. Here is our original stress element, and then here is our rotated stress element with our principal stresses. If you wonder what this little diagonal right here is, I'll remove all my ink so you can actually see it. This is the max in-plane shear stress, and this is the average normal stress. That's why it's cut at a 45-degree angle. So it gives you everything when you show it that way. Okay. Now, if we want to find our absolute maximum shear stress, then that would simply be equal to our principal stress divided by 2. And there are a few equations for this. We can look at the book right there for chapter 12 to see this. All it is simply going to be dividing our maximum shear stress by, maximum normal stress by 2. Okay, that's it for this time. Thank you so much for listening, and I'll see you all later. Bye-bye.